Okay, so we are going to do some more practice on our enthalpy of solution calculations, okay? So, let's work through this one, okay? So this is a nice wee one for us, and there's obviously two steps in it. We're going to have to work out the energy change first, and then we're going to have to work out the enthalpy, okay? So that should be okay. What we're going to do is, we're just going to work through this like we were doing before. Okay, so we've got 4 grams of ammonium nitrate, completely dissolves in 100 centimetres cubed of water. That's going to be our mass of water right here, in an insulated container. The temperature of the water falls, okay, so that's obviously going to be endothermic because the water loses energy, so the chemicals must gain energy, okay, and it falls 3 degrees Celsius. Okay, so let's work out the energy change first. So our wee equation, E equals Cm delta T, 4.18 times, and remember it's the mass of water, that's going to be 0.1 because we've divided 100 by 1,000 to change it into kilograms, and our delta T, remember we said was 3 degrees. Okay, so that should work out to be, put it in your calculator, plus, because it was endothermic, it was a temp decrease, 1.254 kilojoules. Remember it's endo because there's a temp decrease. And I think that's the first time you guys will have saw an endothermic calculation that I've done with you. Now, what we need to do is we need to actually work out the GFM and then calculate the energy released with 1 mole. So let's do the GFM up here. So it was ammonium nitrate, which is NH4NO3. So that's 1 times 14, because nitrogen is 14. We've got 4 times 1, because we've got 4 hydrogens. We've got another 1 times 14, because we've got 1 nitrogen. And we've got 3 oxygens, which is 3 times 16. And if you calculated and added all them up together, you would get a gram formula mass of 80 grams. That means that 1 mole is going to have a mass of 80 grams. Let's work this out. So, we know from our equation that we've calculated already, our energy change when 4 grams is dissolved is going to be plus 1.254 kilojoules. We're going to work it out for 1 mole, which we said was 80 grams, and we're going to do nu over old times other side. Nu over old times other side. So that's 80 divided by 4 times by 1.25. And that is the same as times it by 20. 80 divided by 4 is 20. And that gives you plus 25.08 kilojoules per mole. And remember it's plus because we said it was endothermic. I'm just going to do the cross multiplication for you guys that want it. You're going to do 4 divided by 80 is the same as 1.254 divided by x. X is going to be 80 times by 1.254 divided by 4 will give you plus 25.08 kilojoules per mole. And there you go. I'll leave that there for you to look at. Okay, so let's try another calculation. This one is a slightly different type. Remember when it's asked, it tells you in moles already. You could argue this is maybe slightly easier because you don't have to work out a gram formula mass. But let's work through this. Okay, so we've got 0.3 moles of a salt is dissolved in 0.25 kilograms of water. There's a rise in the temperature of the solution from 17 to 23 degrees Celsius. So if you work that out, that's 6 degrees of a rise. Let's calculate the enthalpy of solution of this salt. Okay, so first part is to work out the enthalpy, the energy change. So that's E equals Cm delta T. C is always 4.18 when it's water. Tells you the mass of water is 0.25. And the temperature change is 6 degrees. Because it goes from 17 to 23. So the answer there is going to be 6.27 kilojoules. And it is negative because it's exothermic, because the temp increases. So hopefully that makes sense. What we're going to do now is we're going to now work out the enthalpy change for this. Okay, so we've done the energy change, let's work out the enthalpy. So we know that 0.3 moles gives us negative 6.27 kilojoules. Let's find out 1 mole. So that's going to be 1 divided by 0.3, new over old times other side. And when you do that, you end up with 1.333 times by 6.27. You end up with the answer being minus 20.9 kilojoules per mole. And remember, it's per mole when it's the enthalpy. So hopefully that makes sense for us. Let's do the cross multiplication for those who need it. Okay, so we'll do, it's going to be 0.3 moles over 1 mole equals 6.27 kilojoules divided by x. So x is going to be 6.27 times by 1 divided by 0.3, and your answer is going to be minus 20.9 kilojoules per mole. There you go, and that is your answer. Okay, so let's make sure we understand it's exothermic because the temperature of the solution increases, and we know that we are doing per mole because it's enthalpy and it's always 1 mole. Okay. If you need any hand with any of the questions, then you know you can ask your teacher. Okay, but that is it for today. Go and work on the questions now, and hopefully those are making sense for you.